When thinking about the search for technosignature evidence of alien civilizations, finding intelligent alien life, or at least trying to, there has been an increasing number of speculative ideas on just what we could look for. This is necessary. It's how you come up with ideas on what to look for in the first place. The best scientific speculative thought has come up with is a range from technosignatures to megastructures, basically the same thing, and a number of others, whether radio signals, infrared emissions, or otherwise. But one interesting and somewhat really speculative idea is the so-called red spiral concept. Spiral here being a true spiral or a barred spiral galaxy like our own Milky Way, where if you saw a relatively nearby galaxy that appeared unnaturally reddened, it would indicate that this galaxy had been engineered to be that way. So we know a spiral galaxy can support life, or else we would not be here. So a distant spiral galaxy needs two things for this. It needs to be close, otherwise you see it as it once was before it had time to form planets and life to arise, because it takes time for light to cross space. It needs plenty of supernovas and kilonovas to create heavier elements needed for planets. You need a lot of fusion to make a galaxy have the materials it needs to make planets, and thus life, so far as we know. So only the closest galaxies will meet these criteria. But at the age of the universe now, 13.8 billion years is the best estimate today, the galaxies we see should be a mixed bag of old and young stars, as the Milky Way is. But the red spiral idea is predicated on the notion that basically the aliens of that other close spiral galaxy eject out any dangerous stars, and basically make their galaxies supernova-proof at some stage. This would have the effect in a spiral galaxy of reddening it unnaturally if someone had done that. Worth noting, these have been looked for to some degree and nothing has been seen. The reason for this is that supernovae are dangerous. They can bathe nearby worlds to them in dangerous radiation if they're close enough. An impending supernova is a no-go zone for many light years around it, and when they cook off, they are most definitely an extinction-level event for some fraction of the planets in any galaxy. It's worth noting here that galaxy evolution is such that some types of galaxies may not be good for life at all. Some are not. Too young for the materials, too compact, and other reasons place some of them in at least the unlikely gray basket for life, even if they have millions or billions of star systems. But there are ways around that. Ice shell moons with their armor of ice, special exoplanets in unusual circumstances, some of which, perhaps, we have never envisioned yet, and so on. But all of this gets much worse of a threat in certain areas of a spiral or barred spiral galaxy like our Milky Way, or for that matter, particularly compact young galaxies that may never see the advent of life in their entirety, simply because the stars are too close and too many explode, gamma ray bursts, etc. But it also applies to galactic cores and also dense star clusters. But what you can do with a galaxy as an advanced enough civilization is eject stars under the right physical conditions and effectively evict dangerous stars before they become an explosive problem for you. That idea, however, assumes, and assumptions are always an issue in science, that a civilization would go through the trouble of ejecting stars in order to colonize every single suitable star left after the ejection. Aliens may not do that. Just avoid colonizing star systems that are in a supernova danger zone, rather than go through the titanic effort of ejecting so many giant stars. But one must always bear in mind that we look for what we can think of to look for in the search for extraterrestrial intelligence, and we really have no idea what an alien civilization would or would not do. We haven't a clue. There aren't as many rules here as you might think. Just because we think one way does not mean that aliens in their own situation may not think a completely different way. But there is a variant of the red spiral idea that might make significantly more sense than engineering an entire galaxy. For whatever reason, probably practicality, you may not go that far. Instead, what you might do is basically ignore 90% or more of your galaxy because interstellar travel is simply too time-consuming and too hard, other than perhaps robotically over very long geologic periods of time. With machines, you can colonize an entire galaxy, like the Milky Way, in a few million years at sublight speeds. But with biological beings, That's a lot more complicated. So aliens, and for that matter future humans, may not do it at all. They may stick to near stars. And there is one specific way to do that and still colonize a huge number of star systems, albeit extraordinarily long-term by our standards, but maybe not for the standards of a future humanity or aliens that have been around for millions of years. Stars pass close by each other in galaxies regularly. Our own star system has seen other star systems pass within the Oort cloud at various times in the past. And this has happened over the course of the history of the Earth numerous times. It will happen again. So you can simply colonize those star systems as they pass by. It's much easier to travel 1 light year during a stellar encounter lasting thousands of years that you know is coming and can prepare for than it is traveling 4.5 light years to the currently nearest star. But it wasn't always the nearest star, and someday will not be the nearest star anymore. The Alpha Centauri system's current proximity is an effect of a stellar encounter, just not one as close as they can get. Even if they don't have a suitable world, there's always terraforming. And given that stellar encounters can last tens of thousands of years, you would have plenty of time with sufficient technology, and off goes your colony into the galaxy to wander like we are, and keep contact for as long as we can. But if we ever run into them again, we may not even mutually realize we come from common roots. But stellar encounters are a galactic thing. It happens all over the Milky Way and in other galaxies. But there are environments in the Milky Way where stellar encounters happen much, much, much more frequently. And those stars do not necessarily get out of communication distance with each other. The answer is to kick out all of the dangerous stars out of a star cluster, and then comfortably keep all the good stars which are naturally clustered together. You need to do a lot of stellar engineering and repositioning, but there are several reasons to do this. So the globular clusters of the Milky Way are ancient, and a majority of their giant stars have already evolved or died in a supernova, leaving only remnants of the former giant stars such as white dwarfs, which no longer present a threat and can themselves be used for energy collection. You still have other threats, but these stars are suitable so far as we know, and if they have planets and materials, which we know that there are exoplanets and star clusters, just seemingly not as many due to planetary formation being ostensibly harder in a cluster. But you can also make your own planets if you're advanced enough to colonize a star cluster. But there is an interesting aspect here. If you have the materials in a cluster, one thing about globular clusters is that they are dense in stars, meaning they are incredibly energy dense, having that many stars to work with. Especially if you're creating Dyson swarms, energy collectors around stars, where you've either colonized or built a world out of the materials you have available, allowing for the cluster to be a veritable super powerhouse of energy for a Kardashev Type 2 civilization. Only a galactic core can outdo the available stellar energy of a globular cluster, and some have on this basis suggested looking for alien technosignatures in the Milky Way's central bulge because of this available energy. This used to be a no-go territory for SETI in general. It did not seem like life could arise in the galactic core. It's not in the so-called galactic habitable zone. It's well inside its inner edge. But again, we don't know what highly advanced aliens might do, especially if their motivation is being hungry for energy, as Nikolai Kardashev saw it. There, the core may be the low-hanging fruit if you can protect your planets you're colonizing, which is in principle possible. This might make for something a technologically advanced alien civilization, say Type 2 or 3 on the Kardashev scale, might choose to colonize if efficient energy production is their goal. It's also significantly easier to build a colonial star empire because everything is much closer together, rather than spread out as with much of the rest of the galaxy. But not much thought has been put into the clusters, though it's worth noting that the famous Arecibo signal was pointed towards a star cluster, specifically because there were more chances there for someone to pick up our one-off wow signal. There is a marked difference here, however, in that our area of the galaxy averages 5 to 10 light years in general spacing between stars. It can be closer, but that is the average. But a globular cluster is more like a 10th to 1 light year average distance, with the galactic core being much denser. But that also creates a problem in that when you get in a dense core like that, you can have stellar collisions, and that might put the brakes on this idea unless you create an anti-collision system by moving stars around with Shkadov thrusters, if you have time to do that. Shkadov thrusters take a long time to get moving, so you would need a large lead-in time to do any of this. This probably means you aren't from that star cluster originally. You just happen to be close enough to it to send your von Neumann probes there and start preparations. Again, this requires very advanced technology. We do not know what alien civilizations have. This should, however, again redden the star cluster in a distinctive way, but I suspect the effect would be less, far less, than that of an entire galaxy, since you're naturally dealing with mature stars. It would probably not be as pronounced of an effect as the red spiral idea advances. Thus, this kind of engineering may be significantly harder to detect, something like a slightly more reddened star cluster than it normally would be. But it's an interesting concept, if futuristic indeed. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently perplexed by the red spiral concept. You'd also think that there would be other evidence of that, such as a halo of dangerous stars heading out of the galaxy. I don't know how detectable that would be, but interesting stuff, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.